Welcome to Study Loop.
So in this problem, we are given with the reaction of the formation of the phosphorus pentachloride from the reaction of phosphorus trichloride and chlorine gas. We are given the value of Kp for this reaction and given the partial pressures or the initial partial pressures of each of the reactants and products. So in first part of this problem, we have to calculate the reaction quotient, and from there we'll have to determine which way the reaction will proceed to reach the equilibrium. So if we write down the reaction quotient expression for this reaction in terms of pressure, it will be the partial pressures of the product over the partial pressures of the reactant. And if we just plug in the values, it will be 0.20 atm over 0.50 atm times 0.50 atm. And this will give us a value of 0.8. So this is the value of reaction quotient in terms of pressure for this reaction. Now if we look at the equilibrium constant in terms of pressure, Kp, we can see that the reaction quotient is greater than the value of equilibrium constant. That means to reach the equilibrium, we need to decrease the value of reaction quotient to have the value of the equilibrium constant. And if we want to decrease the value of the reaction quotient, what we have to do is we have to decrease the partial pressure of the product, and we have to increase the partial pressure of the reactants. So that means the reaction need to go in reverse direction to reduce the partial pressure of the product and to increase the partial pressure of the reactants. That means the reaction uh, must proceed in the reverse direction to reach the equilibrium for this case. Now, the second part of this problem, we have to find out the equilibrium partial pressure of the gases present. And to do that, what we have to do is we have to set up an ice table. So the reaction here is BCl3 plus Cl2 give us BCl5. Now, the initial concentrations for the initial partial pressures for all the gases are given. So for BCl3 it is 0.50, for chlorine it is 0.50, and for BCl5 it is 0.20. Now if you consider the change as x, and as we have seen that from the reaction quotient that the partial pressure for the reactants need to be increased. So the change for both the reactants will be plus x, because we need them to be increased to reach the equilibrium, and we need to decrease the partial pressure of the product to reach the equilibrium. That means the change for BCl5 will be minus x, and that means that the equilibrium concentration will be for both the reactants it will be 0.50 plus x, and for the product it will be 0.20 minus x. Now if we plug their values in the equilibrium constant expression in terms of pressure, so it will be Kp equal to the equilibrium concentration of the product, the equilibrium partial pressure of the product over the equilibrium partial pressure of the reactants. And if we just plug in the values, the product equilibrium pressure is 0.20 minus x, and for both the reactants it is 0.50 minus x, so we can just write 0.50 minus x whole square. And we know the value of Kp, which is given as 0.0870 will be equal to 20 minus x and 0.50 minus x whole square. So if we solve this equation, we'll get a quadratic equation like this: 0.0870 x square plus 1.07x minus 0.178. And if we solve this equation by taking the x equal to minus b plus minus root over b square minus 4ac over twice a, it will be, so our b value here is 1.087, so it will be minus b, that means minus 1.087 plus minus root over b square minus 4ac, that means 1.07 square minus 4 times a, which is 0.0870 times c, which is this, that means minus 0.178. So it is b square minus 4a is this one, a times c, which is minus 0.178, and it will be put over twice a, that means 2 times 0.0870. And solving this, we'll get two values, and here one will be a negative value for this minus, and we'll ignore that and we'll just take the positive value, and the positive value here is 0.16. So this is the acceptable value for the x, and now if we just plug in the values of x in the equilibrium partial pressure, so you can get the equilibrium partial pressure for each of the gases. That means the equilibrium partial pressure for ECl3 will be 0.50 plus x, that means, oh yeah, so it will be 0.50 plus x, that means 0.50 plus 0.16, and this will give us a value of 0.66 atm. This will be same for the Cl2, which is 0.50 plus x, that means for Cl2 it will be also 0.66 atm, and for PCl5 it will be 0.20 minus 0.16 atm, will give us 0.04 atm. So this is the these are the partial pressures or the equilibrium partial pressures for the gases present. Now in part C of this question, we are asked to find out what effect will increasing the volume of the system have on the mole fraction of chlorine gas in the equilibrium mixture. So if we increase the volume, the effect will be that the equilibrium will move in a way where there are So if you increase the volume, the equilibrium will shift in a way where there are more number of molecules present. So if we look at the balanced equation, you can see that in the reactant side we have 1 plus 1, total 2 molecules. In the product side we have 1 molecule. So we have a higher number of molecules in the reactant side. That means if we increase the volume, the equilibrium will shift to the left, and that means it will increase the amount or the mole fraction of chlorine in the mixture. So the answer to the question C is increasing the volume will increase the mole fraction of chlorine. Then in part D of this question, we are asked to find out if the reaction is exothermic, what effect will increasing the temperature of the system have on the mole fraction of chlorine. Again, if the reaction is exothermic, that means the forward reaction rate increases at lower temperature, and the backward or the reverse reaction rate increases at a higher temperature. Since it is exothermic, exothermic means heat is also a product. That means increasing the temperature will increase the reverse reaction rate, so that some of the heats are decreased. And that means for this reaction, since it is exothermic, if we increase the temperature, the reaction will go in the reverse direction, which will also increase the mole fraction of the chlorine. The answer to question D is the mole fraction of chlorine will be increased in the equilibrium mixture if the temperature is increased.